well, I mean, we can use the calculator to kind of help, but mostly by hand. So the amount of time in minutes that a person must wait for a bus is uniformly distributed between 0 and 15 minutes inclusive. What is the probability that a person waits fewer than 12.5 minutes? So I'm going to start, I'm kind of visual, so I like to have my picture and just make that rectangle. We're going from 0 to 15. If it's uniformly distributed, everything has the same chance of happening. So if I want to find this probability for the chance that everything happens, that's my 1 divided by the max minus the min. So my max is 15 and my minimum is 0. So we're really going to be left with 1/15. And what is that as a decimal? That's really small. All right. 0.067. It's just 6 repeating? Okay. All right, and then I want to know, so that's my chance for every single event, and I want to know about 12 or fewer. 12.5. So somewhere up here. And this side. Oops. So what I really want, since we're talking about an area, we're talking about the area of this curve. I want to know what the area of that shaded region is. Is there anything we can think of to find that area?
Multiply.
We can multiply. Remember from algebra, the area of a rectangle is length times width, or length times height, whichever one. So, we're not going to integrate. Calculus is not a prereq for this course. So, I want x to be less than or equal to 12.5. That's the probability I'm trying to find. In the uniform distribution, finding the probability is the same thing as finding that area of that rectangle. We just found that the height of this, or the width of this, was that 0.067. The length of this is my 12.5 down to where I stop. So minus 0. You don't have to write the 0. I just want to make sure we know what we're finding. So I really want to know what 0.07 times 12.5 is. And let's see what we get. Because I need to figure out the length of this piece. So it's the distance from 12.5 down to the minimum. You got what?
I got 0.8375.
375? Does everyone agree? All right. So then you could tell me that the probability a person waits fewer than 12.5 minutes is 83.75% of the time. Questions on it? No? All right, it says on average, how long must a person wait? Find the mean and standard deviation. So I'm going to use the formulas they gave me. The mean was a plus b divided by 2. Well, my a is 0, and my b is 15, and I'm dividing by 2. So 15 divided by 2 gives me 7.5. Then if I want the standard deviation, that's my formula with the dividing by 12. So I'm going to do b minus a, so 12.5 minus 0, square it, and divide by the 12. So the square root of 12.5 squared divided by 12, what does that give us? Oh, you're right, my b is 15. Ignore me. So we want 15 minus 0, and then the square root of 15 squared divided by 12. Sorry about that. .33. Gotta do the square root at the end. So you found the variance. All right, if I want to answer their original question, which is, on average, how long must a person wait, what would you tell me? 7.5, right? We're talking about the average, which is the same thing as the mean. So, on average, a person waits 7.5 minutes. Questions on that? All right, 90% of the time a person must wait falls below what value? Now they gave me a percent. How do we get percents, or where do the percents come from? Well, in part A, where did we get our percent from? Finding the area of that rectangle, right? So they just told me 90% of the time people have to wait fewer than what amount of time? That means they told me the area of this rectangle. What they didn't tell me is this X amount down here at the bottom. That's what they want to know about. They want to know what number is the time limit that people are waiting less than 90% of the time. Less than that amount 90% of the time. To 10%?
Yeah, because it says 90% of the time the person waits must fall below what value. So I just thought it was the little sliver, but I guess it's going to be the same.
Well, the little sliver would be you're waiting more than that amount, right? So this 10% would be waiting more than whatever this X value is. So we can figure out the time. Actually, you could use both to figure it out. You could use either one to figure out your number. But we want the 90% to be the smaller amount of time that they're waiting. So I'm going to have to reverse a little bit what I did. They told me the area this time. And remember, we probably want to work with this as a decimal. So we'll work at it as at 0.9. So last time we had that our probability equaled the length times the width. So this time we're going to have our probability, which is 0.9, still equal the length times the width. And you can use the 1/15 or the decimal, doesn't matter. And I want to put that I'm multiplying by, it would be x minus 0, which just gives us x. So we do have to do a little bit of algebra. How am I going to figure out what x is? Divide both sides by 0.067. And that's going to tell me that x equals 13.43. And like I said, you could have done 0.9 and had the 1/15 times x. and multiplied both sides by 15 to get the same thing. It might be a little bit different due to rounding. What does that give you? 13.5? But either one should be fine. So it depends on whether you rounded to begin with or you're using the whole number. Either one I will accept. And then you would tell me 90% of the time a person weighs less than 13.43 minutes. Or 13.5 minutes if you use the 15, either one. I like to have the picture, so I draw it. And I say, okay, I know that I'm in between 1.5 and up to 4. Then what I need is I need to figure out the probability, or how high am I here. So P of x is 1 divided by your max minus your min. So 4 minus 1.5. So 1 divided by 2.5. What does that give you? 0.4. So the probability of each event is going to be 0.4. And then it wants to know, find the probability that randomly selected furnace repair requires more than 2 hours. So more than 2 hours means I'm here at 2 and I want to know about this side. 2 up to the 4. So the probability that x is greater than 2, I want to find the area of that rectangle again. So length times width. I've got the width we just found is 0.4. And the length is going to be 4 minus 2. Because I'm going to have a max of 4 and I'm going to be down to the 2. So I'll figure out my total distance. So 0.4 times 2 gives me 0.8. So the probability a furnace repair requires more than 2 hours is 80%. I want to find the 30th percentile. That means they gave me a percent. So what does that tell me? Work backwards, right? So 1.5, 4, 30%. That's not 30%. There's 30% and there's some cutoff that goes along with that. I want to figure out what that x cutoff is. And I still know that it goes as high as 0.4. Each one of them has a probability of that 0.4. So I'm going to set up my formula in reverse. I already know the area of the inside. We're going to use 0.3 so that we can work with it. I have my height of 0.4. Now I need the length. How can I figure out what the length is? X minus 1.5. So this one's a little bit different from that 90% one because we aren't going all the way to 0. So the distance isn't just going to be x. We have to account for the fact that we're stopping at that 1.5 and subtract it from there. The setup is the hard part. Then I have to do some algebra. So let's divide by 0.4 on both sides. So 0.3 divided by 0.4. Oh, 0.75. All right, let's put that. 0.75, and then I've got this x minus 1.5 left. And how do I get x by itself?